Okay, we're live. So I'll be leading this group discussion, and we should start off with a prayer. And Sister Lemon, I was wondering if you could offer us the opening prayer.
Perfect. Our dear gracious Heavenly Father, we're thankful for the opportunity we have to meet as a group. We're thankful for the opportunity to be at BYU, Idaho, and for this program that reaches out for giving higher education all over the world. I'm grateful for the means to provide that. We're grateful for the gospel in our lives, for the atoning sacrifice of thy Son. We ask for a special blessing on those in Puerto Rico, that they may have their needs met, and their needs met. We're grateful for all those that are serving and willing to help, and we pray that they may know of our thoughts to them. And we pray for these things in thy Son, Jesus Christ. Amen.
Amen. Thank you. All right, so this lesson learned about density curve and z-scores. Did anybody have any questions on anything from the textbook or from the assignment that we had? Okay. All right. And also, just as a reminder, we do have those homework quizzes to turn in by Saturday. But if no one has any questions, we can go ahead and jump into the group meeting quiz, if that's okay.
Yeah.
All right.
Okay, you techie guys, how do you get, you guys have two windows open? So you have like Google Hangouts on one and or you just
that's what I'm
back
doing.
and forth. I'm like,
Yeah.
why do I always end up in the same one and I just have to flip? I'm like, I need to have like Google's Hangouts over here and Google open over here. Make it a little smarter.
Yeah, that's what I do. It makes it easier for me to look at both screens.
How do you split it? Do you just copy and paste the Google Hangout in an open screen?
Well, you can do is you can go up and click on the tab, and then you hold it down and you drag it over, and it'll become its own window.
Oh, got it.
Then you just need to resize both windows.
Nice. All right. Thanks.
Okay. So the first two questions are self-explanatory. But I'll go ahead and start off with reading off the third question, and then we could each take a turn reading the question after that. So I'll go off and I'll start off with reading the information bit right there before question 3. It says, while you are required to work together on this quiz, each member of the group must submit his or her own answers in order to receive credit. If we need it, there's a link for the normal probability applet when calculating anything.
Bookmark it. You need it for the exam as well.
All right. So when calculating anything, remember to round to 3 decimal places, unless otherwise specified. Do not round until your calculation is complete. Okay. So question 3 says the total area under a normal distribution curve must equal. This one's going to be 1.
Yeah.
Yeah, because all the area underneath the normal distribution curve should be 1. If it's anything different, I believe that would not make it a normal distribution curve. Yeah.
I'll take the answer. Under certain circumstances, a normal distribution curve can drop the over x-axis. That would be false because it's supposed to be above every time over believe.
Yep, it's true.
Wait, question 4 says false, as I was saying, and you just said, yeah, that's true, it's false. So,
Yeah,
Oh, yeah.
okay, I got you. Okay.
Yeah. Okay, William, could you take the next one?
I'm having a little trouble getting mine loaded. I'll be, just give me the next one. I'm still looking it up, I guess.
Oh, okay. All right, so Sister Lemon, are you with this on us, or are you just kind of watching?
No, I got one open.
Okay. Could you read number 5 for us?
A normal distribution curve is symmetric.
Okay, I'm going to say that one's true because since it's bell-shaped, it's going to be symmetric.
Yeah, if you divide it down the middle vertically, it mirrors itself on either side. So yes.
Okay. Awesome. William, just let us know when you're there.
Okay.
All right. So for question, or actually maybe we should just wait. Or is it just loading, or?
Yeah, it's just loading. It's okay. I'm still listening.
Okay. All right. So for question 6, we have the bell-shaped thing. I forgot what that's called. It says okay. It says, which of the following elements of the figure represents the z-score? It's going to be C.
Is everybody clear what a z-score represents?
Yep.
Z-score. I have the definition written down, but I guess I don't know it well enough to explain it. Could you refresh my memory?
Yeah, and it's yeah. So, and I'd love for you to just kind of get context around it without memorizing a definition. So the idea, if you think about the formula, the top part, right, what we call the numerator, is a subtraction, and subtraction gives us distance. So what you're doing is you've got some data point, and the first thing you're going to do is figure out the distance it is from its mean. So that's the subtraction. So data point minus the mean, that tells me distance. And then I divide that by the standard deviation value, which then puts it in unit of measure standard deviations. So if I have a z-score of 1, that tells me the data point is equivalent to living 1 standard deviation away from the mean.
Okay.
Does that make sense? Then if I had a z-score of negative 0.5, that would tell me the data point lives to the left, that's the negative, of the mean by 0.5 standard deviations.
Okay. I mean, I guess my question over the z-score is, I know throughout the textbook and the videos that we watched, it's been kind of praising the z-score and like I guess the invention of it over the old way of doing it. Forgot the name of that.
Well, the reality is that if you don't have a bell-shaped curve, or you don't have somebody that's programmed in the areas associated with the bell-shaped curve, you have to do some ugly calculus.
Oh, okay.
You know, I don't know if you took calculus, but you have to do integration, and you have a lower bound and upper bound, and then you have an ugly, ugly equation associated with the bell curve to find the area.
All right, so it just makes it easier then, the z-score?
Yeah, so by doing a z-score, we can use a normal probability app or some other pre-programmed scenario that's already got that ugly, ugly equation for the bell curve in there, and it's got it bounded for us, and it does the calculus for us.
Okay. All right, now I see the value of the z-score. I'll leave it on the math. That's awesome. I like that. Okay, William, are you there? Are you at the group meeting quiz?
Yeah, it's number 5, right?
Yeah, it's less than 5. Yes.
Yeah. Okay. I'm in it.
Okay. Have you caught up? We're now on question 7. I don't know if you need us to go over any of the previous questions.
No, it's okay. I'm caught up.
Okay. Could you read question 7 for us?
Yeah. Which of the following elements of the figure represents the probability that the z-score will be greater than 1? And then it's just ABC. Is it the last one?
It should be B.
B.
Yeah, and then we scroll back up to the he is lying outside of he's lying beyond the z-score of 1.
Yeah, a probability is associated with an area. Yeah, so I'm with just the, and it's greater than, so it's got to be that area above the 1. So I agree, B.
All right. Got to be to the right. Okay. All right. Jesse, could you read the next question?
Remember it, right?
Yeah.
According to the 68, 95, 99% rule, what percentage of the data from a density distribution will be within 1 standard deviation of the mean? Right now, it's like a percentage stuff is 42 rather than if it's 14. And that would be 60.
Yep. All right. I'll take question 9. That one says, suppose that z-scores come from a standard normal distribution. Use the normal probability app to answer this question. What proportion of the z-scores will be taken, will be between -1 and 1? Give your answer as a decimal accurate to 3 decimal places. So if the answer was 0.389,184, we would enter 389.39. All right.
So that 68, 65, 99.7 rule is also known as the empirical rule. And it's a really good estimate, super good estimate, but it's not as accurate as using a z-score. But it's not off by much. So what they're trying to do in the next couple questions is kind of get you to compare a little bit kind of general rule, this empirical rule, against if you actually used a z-score, and how do they compare?
Okay.
So basically, we'll just type in 1, and it's wanting us to carry out the decimals further and just 68%.
Yeah, so shade that middle section and then put the 1, which will automatically put the -1 in for that applet, and then look up at the area and see what it says.
So I got 0.6827. Everyone else get the same? Or
Mine's still loading.
okay.
8413.
What was that?
0.317.
Yeah, so then round that to 3 decimal places.
Wait, so how are you getting that number?
So on the normal probability applet, you're going to be putting -1 and 1 for the z-scores. So -1 will be on the left and 1's on the right. So it's asking us what's the area between those two scores, and we just shade the middle section of the
Oh, I see.
bell
Okay.
diagram. Yeah. And then you get this BA area on top.
0.68217. Yeah, okay.
Yeah. And then you just rounded that up to 683. All right. Okay, Sister Lemon, could you get the next question, question 10?
I can. Hold on, I cut it off. All right, question 10. Suppose the z-score come from a standard normal distribution using the normal probability applet to answer this question. What proportion of z-scores will be between -2 and 2?
Okay, so it's the exact same thing as the previous question. We're just changing out the z-scores.
Correct. So now you're going out 2 standard deviations instead of just 1.
We're at 0.995. 9945, but 995.
Wait, which one? For -3 and 2, you got 0.9 what?
955.
Yeah, 0.955.
Yeah.
Yeah, me too.
So you can see they're really close. 0.683 versus 0.68, 0.95 versus 0.955.
Yeah. Yeah. Okay. Jesse, could you get the next question?
Right. Suppose that z-scores come from a standard normal distribution. Use the normal probability applet to answer this question. What proportion of the z-scores will be between -2 and 2?
0.997.
Yeah, which that one's right on to 3 decimal places. So it's a good rule. Just FYI, unless they specifically ask you to use that rule, you need to always go through the z-score and the normal probability applet to be more accurate. But if they specifically say to you, using the 689599.7 rule, then yes, use the rule. But if they don't, you don't use it.
All right. Okay, so question 12, it says, look carefully at your answers to the last 3 questions. What do you observe? You go with the first one, the values match the 689599.7 rule.
Yeah.
All right. William, could you get question 13?
Yeah. Use the following information to answer the next 6 questions. Just the amount of protein that an individual consumes is different for every person. There are solid theoretical ideas that suggest that protein requirements will be normally distributed in the population in the United States. The protein requirement is given in terms of number of grams of good quality protein that must be consumed each day per kilogram body of weight. The population mean protein requirements for adults is 0.65 grams, and the population standard deviation is 0.07. Question 13. What proportion of population have a protein requirement that is less than 0.6?
Okay.
So these next 6 problems, these are very typical of what you can expect to see on the first exam, among other things. All right, so how are we feeling about this? Like, where do we start? Or I got an idea, or?
So I think we divide the deviation for that individual value by the standard deviation to get the z-score. They type that into the applet. Maybe just highlight the area that's below that, and that should give us.
Yeah, so one of the key things it's asking you for the proportion. And so if you need to figure out a proportion and you're dealing with something that is normally distributed, you've got to find that area under the curve. So we all get there? How many of you guys are visual learners? Are any of you visual?
I am definitely a visual learner.
Okay, I'm going to share my screen. I'm a visual learner, so I'm just going to share my screen. I'm just going to show you how I kind of attack these. And again, it's just kind of from a visual point of view. Let me grab this. All right, can you see my screen?
Yes.
Okay, so I'm gonna people saw write terribly, but if follow. So first of all, it tells me it's normally distributed. So the first thing I know is I can draw this bell curve. And it tells me that the mean was 0.65, right? And it told me this standard deviation was, sorry, I have to go back and look. .07. So standard deviation is 0.07. And it's asking me what's the probability that somebody's going to have a protein level of 0.6 or less. So, I mean, it doesn't have to be perfect, but I know that 0.60 lives down here. And so here's where all the 0.0 and less lives. Does that make sense?
Mhm.
Yeah.
Okay, so I don't know how to find this area unless I've had some pretty advanced calculus. So my thought is, okay, but I can use that normal probability applet if I can take this value and turn it into a z-score. So I'm just gonna take the formula for z-score. So data point minus the mean divided by the standard deviation. So negative 0.05 divided by 0.07. You with me?
Yeah, I'm there.
Everybody. And so you get negative 0.714. So that tells me negative because it's to the left. And then 0.6 is equivalent to living basically 70% of a standard deviation away from the mean. Does that make sense?
Right, so that's going to be our answer.
No, that's our z-score.
Okay.
And so now you've got to use that normal probability applet. And see, because I visually got it for myself, it's pretty easy. I go in and I don't put in 0.60. I have to put in a z-score. So here's the z-score equivalent to 0.60 for this situation. Then I just shape the area to the very far left.
Okay. So then our answer is going to be the area for that shaded part.
Yeah, the proportion or the probability is associated with the area. Yep.
Okay.
That's coming at 0.2376.
That's what I got.
Yeah, me too.
So round it to 3 decimals, you get what?
0.238.
238.
Okay, so basically what it's telling me is, if I change it into percentage, 23.8% of people have a protein level of 0.60 or less. Does that make sense?
Yes, makes sense.
And that's kind of the critical piece of statistics. It's all about trying to understand what proportion of people or subjects fall in a certain situation.
Okay, that's kind of cool. I can see how this would like be very useful for statistics. I mean, obviously because it's in a class, but I don't know. I just see like the real world uses for that. It's really cool.
It's a lot. I mean, you think about it. I mean, when you I worked in dealing with the stock market, and a lot of times we look at trending, and we would look at, you know, what proportion of certain things fell at certain time of the year to look at when's the best time to invest in certain areas. But it's statistics is the facts of what's happening and how people think and what they do.
Mm-hmm. Okay. All right. So I'll read question 14. That one says, what proportion of the population have a requirement that is more than 0.60? All right.
So do
So
we just shade everything else in the probability out?
Yeah, you could do that. You could unshade the far left and shade
Just
the
the rest.
middle and the right, or you can, which is really just the complement rule too, right?
yeah.
So you could go 1 minus 0.238 as well. Either way works perfectly. And there's no right or wrong. Whatever makes sense in your brain, that's the way to attack it.
Okay. Yeah, I was gonna do the 1 minus, but the
Yeah,
shading of the
that
curve
totally
is way
works.
easier.
Yeah, and just
Okay.
it's what makes sense in your brain is what you need to go with. There's usually more than one way to attack it that it totally works, and it just needs to be what kind of fits the way your brain thinks.
Okay. Okay. Jesse, could you get question 15?
What proportion of the population have a protein requirement that is less than 0.70 grams? So that would be another deviation of 0.05, which is the same Z-score. So it would be the same. The same as that inversion of question.
A nice logic, Jesse. And again, if you can understand that logic, that's awesome. If you don't, just go through that same process. Draw in your 0.7 this time. It's going to be over here. And you need to find, and now you're looking for this whole area. So first you've got to get a Z-score associated with that.
And that's the whole equation where it's 0.7d minus the mean divided by the, okay.
Yep. You're going to find that distance, the distance between 0.7 and 0.65, and then you're going to change the unit of measure to standard deviations. But I think if I understood you right, Jesse, you were saying, hey, 0.7 is the same distance as 0.6, just on the other side. Therefore, it'll have the same Z-score, just a positive. Is that what you were saying? Did I understand that right?
Yeah,
That's
yeah.
great
So
logic. And therefore, that area from 0.6 up is the same area as from the 0.7 down. Okay, yeah, that's great logic. But again, that's awesome logic. But if you don't have that, if that doesn't naturally come to you, it's no big deal. Just go through the process again, and you'll come up with the same answer Jesse did.
0.762.
Mm-hmm.
Okay. All right.
So what did you get? Jesse, what did you get, Ralph? Did you get an answer?
Yeah, I got 0.762.
Yeah. Okay.
Okay.
So either way works. Again, either way works. So that's perfect.
Okay. So for question 16, it says, find the probability that a randomly selected person will have a protein requirement that is between 0.60 and 0.70. Remember that to find the area between two values, shade to the left of each z-score, you calculate and then subtract the smaller area from the larger area. Make sure your answer is positive. This is the probability that a randomly selected observation will lie between the two values. And then give your answer as a decimal accurate to 3 decimal places.
Okay, so they gave you all this information, and it's really true. If you take from 0.7 down that, and then subtract off the proportion from 0.60 down, totally works. But also notice that the z-scores are equivalent, but one's negative and one's positive. So the shortcut when you have the exact same z-score values, because is that we are allowed to shade that middle section of the normal probability applet.
Okay, yeah, that makes it way easier. I was going to ask about that too.
Yes,
but
that's the shortcut, but it only works if the z-scores are the same. Otherwise, what you'd have to do is you'd have to take 0.762, wasn't that it? Minus 0.238, right? This whole probability minus that probability, or you can just shade the middle on the normal probability app. Either way, you should get the same answer, which is
0.523.
or was that point? Did I round that right? Was that point? Yeah, 0.6. Yeah. Or 0.238. Yeah, I get it. Okay, so what's your answer?
0.525.
Okay.
Okay.
So if you do it this way, because of rounding, you get 524, and if you do the middle section, you get 525. 0.525.
Is there a reason that in the applet it always has both sides equal, so you can't, because you could probably do it a little bit quicker if the z-scores on either side do the same. Or is it just because of a math or calculus thing in the applet that they can't do that?
Yeah, it's just programming. It's just it's super hard to program. Yeah, it's super hard to program with the upper bound and lower bound different z-scores. So I think that's just their choice. There are, like if you use an old school graphing calculator, like I have this old school graphing calculator, I can put in 2 different values and it'll work. But that applet they just didn't program it that sophisticated. But you could definitely find other ones that are more sophisticated, and your graphing your high school graphing calculator can handle it. But this applet cannot.
Okay. All right. So for question 17, it says find the 35th percentile for the protein requirement for adults. Round your answer to 3 decimal places. All right. So when we're doing percentiles, this is the one where we're working backwards, right? And you just put is it 0.35 on the area?
Yeah, and you need to make sure you only shaded the far left. When you're dealing with percentile ranking, you shade from the left to the point. So because it's the 35th percentile, which is below the mean, then you're just going to shade the very far left. So you want to make sure you shade just the far left and then put in the 0.35.
Okay.
The applet's not overly sophisticated, so if you don't have the right area shaded, it can throw the wrong answer out.
But do we change the z-scores at all, or do those change it by
No,
themselves?
that's what you're looking for. Basically, I'm gonna draw it out for you. So basically, what's happening is it's kind of saying, okay, this time. So you've got your basic mean bell curve. You've got your mean. And you get your standard deviation. And it's saying, okay, we want to understand what's this X value such that this area represents 35%. So we're looking for the raw score or the raw protein value associated with the 35th percentile. And so the first thing we have to do is we have to back it out. So we've got this. The next thing we have to do is get a z-score. So what does the applet tell you the z-score is?
0.385.
And it should be negative because we're to the left. So be really cognizant of that. If you're to the left of the mean, your z-score's got to be negative.
Yeah.
All right, so now note, I've got a z-score, I've got the mean, I've got the standard deviation, so therefore I can solve for x. So I'm just going to use this formula. Like that. Does that make sense? Does that make sense?
Yes.
So what I got was 35th percentile standard deviation is 0.055.
So you got
So it would be like 5.5.
so you took negative 3.85, negative 0.385, multiplied it by 0.07 and added it to 0.65.
No, I didn't.
Are you with us, William? You doing okay?
Yeah.
Yeah, I keep getting. So my answer, I get 0.3805.
Okay, so this is what so negative 0.385, that's our z-score, correct?
Mm-hmm.
So to solve for x, we got to multiply both sides by 0.07. And then we have to add 0.65 to both sides.
Oh, I goofed. I put 3.85.
Yeah.
That's what I got.
Okay.
Something weird.
It should be like that.
0.625.
Negative 0.385 times 0.07 plus 0.65.
Yeah, 0.623.
Yeah. I think I heard it.
Yeah, that's what I got too.
Say it again.
0.623.
0.623, yeah. Which makes sense. It's got to be a value below 0.65. So basically a protein level of 0.623 puts you in the 35th percentile.
Okay.
It's kind of akin to when you take the ACTs to get into college, and you get, you got a score of 29 on the ACT, and that puts you in the 85th percentile. It's telling you that score represents the 85th percentile. So in this case, with protein, a protein level of 0.623 represents the 35th percentile.
Alrighty. Okay, so I'll get the last one. It says find the 80th percentile for the protein requirement for adults. Round your answer to 3 decimal places. Okay, so it's just like the last one, but I remember in the book it says that we're supposed to shade the left and the middle, right? Because it's over 50%.
Yeah, So again, you just kind of draw yourself out, and you're like, this has to be 80%. And so 80%, right? Because the mean is at the 50th percentile, so you know you're beyond that. So you're looking for this X score over here. So you go through that same process again.
About 0.709.
Yeah, yeah. That's what I got. So did everybody get the same Z-score? What was your Z-score?
Mine was 0.842.
Yeah, I got 0.842.
Okay, so you get a Z-score. Z-score 0.842, is that you tell me? 0.842 equals X minus 0.65 divided by 0.07.
Wait, why wouldn't it be negative 0.842?
He's on the other side.
It's to the right.
Oh, that's right.
Anything to the right of the mean is positive.
Okay.
Because in math, the positive, negative are directional. And because Z-scores are based off comparison to the mean. If you're to the left of the mean, you're negative, and if you're to the right of the mean, you're positive.
Okay. Yeah, I got 0.792.
before you submit.
Yes.
All right, did you guys submit? Did somebody submit?
Oh, yeah, I submitted. I got 100.
Everybody good?
Yeah, I still have to fill out question 8, I guess. But
Question 8.
yeah.
Let's see, I still have mine open. Let's see. Question 8. Oh, one standard deviation is 68%. So the rule is one standard deviation is 68% of the data, 2 standard deviations away is 95% of the data, and 3 is 99.7 for that rule.
Okay.
Does that make sense? All right, so those, like I said, the information on this quiz is pretty heavily hit on the exam, and it's also into lessons 6 and 7. We're going to use it again on what we call sampling mean distributions. But the same idea, the bell curve is there, the mean, the standard deviation adjusts by a little bit. There's a video on the announcement that's like 2 minutes long that you ought to watch to kind of get a visual understanding of the difference between just the standard normal and the sampling distribution.
Okay.
So if you have any questions, make sure you ask them, because this is kind of foundational to what we're going to be doing for a while.
All right. Okay. So if everyone's okay and nobody has any questions, or does anyone have any questions before we end the meeting?
No?
Okay.
Okay.
All right.
All right. Cool. I just wanted to thank everybody for coming today and participating. And just remember to turn in the homework before Saturday. And that's about it. I guess I'll be seeing you all on Tuesday.
Hey, thanks for letting me join you. Let me know if you have any questions I can answer.
Yeah, of course.
All right. Take care.
All right. Bye.
Bye.
Bye.